وعلى آله وصحبه أجمعين. This is section 4.2 and rules of probability, and we reached rule 7, which defines the independence between two events. So we say that two events are independent when probability of E1 given E2 equals probability of E1. We solved one exercise, and let us continue with more exercises. This is a question from the book. Dreamland has its own factory in manufacturing pillows. It manufactures two types of pillows. You can see these two types here, polyester pillows, memory foam pillows. Dreamland distributes its pillows to hospitals, hotels, and department stores. So these are the destinations, three destinations: hospitals, hotels, department stores. So we have a pillow type. This is one variable, and another variable, destinations. The following are the number of distributions made in a day. If I ask you, this distribution they made it in a day, so what kind of data is here? Time series or cross-sectional? Your answer should be cross-sectional because in one day, it is in one day. Okay, some questions about this table. What is the probability that pillows were sent to hotels? Hotels, where are the hotels? These are the hotels. To find the probability that pillows were sent to hotels, let me call hotels uh, T. Okay, I'll call it T. So I'll find probability of T. You add 74 plus 21, you get 95. This is the total number of hotels. Okay, so 95 over the total number of all of everything, of all bills. So let us find the total number. We add 42 plus 74 plus 154. We have 270 here. And we add 34 plus 21 plus 131. So we have 186 here. And if we add 186 plus 270, we get the total number of bills, which is 456. So if we divide 95 by 456, this will give me the probability that pillows were sent to hotels, because 95 pillows were sent to hotels and 456 the total number of pillows. So if we divide them, we find the probability that pillows were sent to hotels. What is the probability that memory foam pillows were sent to department stores? Okay, not any pillow here. He is asking about memory foam pillows, this one. So what is the probability that memory foam pillows were sent to department stores? And he is asking about department stores. So he needs memory foam pillows and sent to department stores. And actually, the number of memory foam pillows sent to department stores is 131, and the total number of pillows is 456. So this is the probability. If I call this F or M, okay, M, and this is P. So he was asking, and this is, let me call this S from stores, and this is H, okay. So he was asking actually here in probability of M intersection S. Memory foam pillows were sent to department stores, so he was asking about probability of M intersection S. You need to read the question carefully to understand what kind of probability he is asking about. A polyester pillow was sent out. So we know that a polyester pillow was sent out. What is the probability it was sent to a hospital? So this is a conditional probability. Okay, we have a fact. We know that a polyester pillow was sent out. So P is there. Okay, and the question, what is the probability it was sent to a hospital? We called hospitals H. So he's asking about probability of H given P. You can use the formula or you can use the method I taught you from the table. So you find the number of P, the number of polyester pillows, it is 270. So we will divide here by 270 because it is the total number of polyester pillows. And we know that the pillow sent was a polyester. Okay, so now what about H? How many of these 270 were sent to hospitals? Only 42. So 42 divided by 270 will give you this probability. Another question, determine whether the pillow types are independent from the places they are sending to. So we have two pillow types and three places, and we need to check whether the places are independent from the types. So what to do? We choose a type, we select a type. Okay. So I will select, for example, uh, the polyester, the memory form. Okay. I will select the memory form, this one, and I will select what hotels. Okay, hotels, and I'll check whether hotels are independent from memory foam pillows. T and M are independent or not. To check whether T and M are independent or not, or all you need to do is to prove that or to find probability of M given T and check whether is it equal to probability of M or not. Or you can find probability of T given M and check whether this is equal to probability of T or not. You can do this or this. Okay. So I will do the first one. So let me find probability of M. Well, probability of M is the number of memory foam pillows, 186 over 456. So 186 over 456. If I simplify this by the calculator, I will get 31 over 76. Okay, let us now find probability of M given T. T is the condition. So the total number of hotels is 95. So I'll be dividing here by 95. And to find M among hotels, so it's 21. So probability of M given T is 21 over 95. Now, if I divide 21 over 95, it would be 21 over 95. This is approximately 0.22, and 31 over 76 is approximately 0.41. So from here, I see that probability of M is not equal to probability of M given T, and this implies that M and T are dependent, not independent, dependent. And if M and T are dependent, then pillow types are not independent from the places they are sending to. So this is a question in which the two variables are not independent. And here you have seen a question in which the two variables are independent. And in both cases, we just try to prove whether this is true or not. If this is true, then E1 and E2 are independent. If it is not true, then E1 and E2 are not independent, as simple as that. Now we go to the next rule, which is the multiplication rule. And actually, this is not a new rule. I mentioned this to you before. We know that probability of E2 given E1. If I ask you what is the probability of E2 given E1, using the definition of the conditional probability, you will say that it is probability of the intersection E2 intersection E1 over probability of E1. If you cross multiply these two, cross multiplication, you will get that probability of E2 and E1, or E1 and E2. Of course, E1 and E2 equals to E2 and E1, is equal to probability of E1 multiplied by probability of E2 given E1. Put in your mind that there is another possibility here, because if I find probability of E1 given E2, then this would be probability of E1 intersection E2 over probability of E2. So again, the intersection can be found from here, but this time it would be probability of E2 times probability of E1 given E2. So you can start by probability of E1 or probability of E2. But if you start by probability of E1, you have to multiply by probability of E2 given E1. So E1 would be the condition. Here E2 would be the condition. So these are two rules you can use for the multiplication rule. Why do we call it multiplication? Because we are multiplying, it's a product. So this is the multiplication rule. Let us solve an example. A small boutique hotel has 20 rooms. So number of rooms in the hotel is 20. Five of the rooms are suites. Okay, so these 20, five of them are suites with a living room and bedroom. Okay, while other 15 are traditional hotel rooms. Good. So the 20 rooms, five of them are suites, 15 are traditional rooms. What is the probability that first two rooms booked? So we will choose two rooms, not one, during the week of October 13, 19 are both suits. And we need the probability that both rooms are suits if the bookings are assumed to be random. Uh, I solved a question before using the tree diagram. Whenever you are going to choose or select two, it would be very nice to deal with a tree diagram or to draw a tree diagram. So let us talk about the first room, selecting the first room or booking the first room. The first room could be a suite, if I call it S, or uh, a traditional room. Let me call it R room. So this is the first room. It could be suite or room. What is the probability of S and what is the probability of R? Well, the number of S is 5, so 5 over 20. 5 over 20 is 1 over 4. Here 15 over 20, which is 3 over 4. So this is the probability of booking the first room. This is S1 and R1, because this is the first room and the first room. Now the second room, what would be the probability of booking the second room? If the first room is S, the second room could be S or R. And if the first room is R, the second room could be S or R. Now, the probability that I'm going to write here now is a conditional probability because it depends on the first choice. Okay, so what is the probability of S2 given S1? Right? Given S1, the number of rooms now is not 20, it is 19. And we have selected one S, so the number of S left would be 4. So the probability of S2 given S1 is 4 over 19. Probability of R2 given S1, 19 in total, and I still have 15 rooms. You can select any one of them. Here, of course, if you add 4 plus 15, you get 19 over 19, which is 1. So pay attention to this. Now, if the first room selected is a traditional room, so the probability of S would be I still have 19 rooms because one room is picked, but I still have 5 uh, S. So here 5 over 19, while here I have 14 over 19 because one traditional room was selected. So these are given probabilities. Now the question he is not asking about given probabilities, he is asking about both suits. Both means he is asking about probability of S1 intersection S2. By definition, S1 intersection S2 would be probability of S1 multiplied by probability of S2 given S1. And probability of S1 is 1 over 4, and probability of S2 given S1 is 4 over 19, and the answer would be 1 over 19. You can think of of this question in another way if you like. You don't have to draw a tree diagram, in fact, but tree diagram will help you in answering many questions, conditional, both, and in case if I ask you what is the probability that the second room is 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 a traditional room, for example. Okay, you can you can يعني listen to the previous video. We illustrated how to evaluate this probability. But here, if you want just to answer the question without graphing or a tree diagram, you can think of the question simply like this. Both are suits. So you think of the first room. What is the probability that the first room is suite? Okay. Uh, how many number of rooms? I have 20. And how many S are there? 5. So this is the probability that the first room is S multiplied by the second room. What is the probability that the second room is S? Given that the first room is S, I still have 19 now because one room has been booked, and 4 because 5, I had 5 and now I have 4. So that's the answer, which is the same answer as this one. The answer would be 1 over 19. If you want to think about it like this quickly, you can get the answer quickly. It's okay. It would be fine. A college basketball team has 10 players. 5 are seniors and 2 are juniors and 3 are sophomores. Okay, so those 10 are divided into 3 uh, groups. 2 players are randomly selected. 2 players are randomly selected to serve as captains for the next game. What is the probability that both players selected are seniors? So the probability that the first one is senior, I can say it is the probability of, uh, if I call seniors, what should I call seniors? Because there are two S, uh, R, okay, let me call them R, seniors. So R1 intersection R2. Both are seniors. So this would be probability of R1 multiplied by probability of R2 given R1. What is the probability that the first player selected is a senior? Well, we have 5 seniors over the total number of players, which is 10 times. What is the probability of selecting the second player, also senior, given that the first is senior? If the first is senior, then we still have 9 players only and 4 seniors. So that would be the answer. Okay, so it's 2 over 9. 20 over 10, 2 over 9. That would be the answer. If you want to draw a tree diagram, it's no problem. You can do a tree diagram here, or you can just answer as quickly as this. X and Y are two events such that probability of X given Y is zero point 0.4, probability of Y is given, probability of X is given. Some questions, what is the probability of X intersection Y? Well, X intersection Y would be probability of X times probability of Y given X. But do we have Y given X in the question? No. So I cannot use this, okay? Or it is probability of Y times probability of X given Y. Is probability of X given Y there? Yes, it's given in the question. So I cannot use this because probability of Y given X is not given, but I can use this. Probability of Y is 0.25, probability of X given Y is zero point 0.4, and this would be the probability of X intersection Y. So it's probability 0.25 times zero point 0.4, the answer is 0.1. So this is the probability of the intersection. Find probability of Y given X. By definition, this is a probability of Y intersection X over probability of X. Y intersection X is X intersection Y, which is 0.1 from the previous parts, over probability of X, which is 0.2. So the probability would be 1 over 2 or 0.5. Find the probability of Y union X. By definition, it is probability of Y plus probability of X minus probability of Y intersection S. This is the formula, addition rule. Probability of Y is 0.25. Probability of X is zero point 0.2 minus probability of the intersection, which is 0.1. So the answer is 0.35. Are events X and Y independent? X and Y independent if probability of X given Y equals X, or probability of Y given X equals probability of X, equals probability of Y. Okay, so which one of these can I find out? Well, both, but probability of X given Y is given in the question. It's 0.4, while probability of X is 0.2. They are not equal. So since, this is the explanation, since probability of X given Y is not equal to probability of X, because 0.4 is not equal to 0.2, okay, this is given in the question. Probability of X given Y 4, probability of X 0.2, they are not equal. So immediately X and Y are dependent, or if you want to say, not independent. As simple as that. Whenever he asks about independence, just uh, make sure that this definition is true. Is it true or false? Okay. The next rule would be multiplication rule for independent events. What would happen if we deal with independent events? Will the multiplication rule change? Okay, let us go back and check the multiplication rule. This is the multiplication rule. If E2 and E1 are independent, what would happen? By the definition of independence, probability of E2 given E1 would be equal to probability of E2. So if E1 and E2 are independent, the probability of the intersection would be probability of E1 times probability of E2, because they are independent. So this is the rule. So this is only true if E1 and E2 are independent. And you can say also, if this is correct, then the two events are independent. So to prove independence, now you have another way to prove independence. Prove that probability of the intersection is probability of E1 times probability of E2. Let us take this example. A small Midwestern city has three major airlines that serve the airport. Suppose that 60% of passengers fly United Airlines. And let us call this U. Okay. So what is the probability of U? 60%. 30% fly Delta. What is the probability of D? 30%. 10% fly Southwest. Let me call S. The probability is 10%. If you add these probabilities, you should get 100 because we have only three major airlines in the city. Further, suppose that 70% of the flyers are flying for pleasure. Okay, 70% for pleasure. Let me call pleasure L. Capital L. Okay. 30% for business. Let me call business capital B. Okay. So there are two different categories now. Okay. Flyers use United Airlines 60% of the time, 30% of the time Delta, 10% of the time Southwest, but also 70% of these flyers flying for pleasure and 30% of them flying for business. Assuming type of trip, type of trip. So what is type of trip? Type of trip, uh, which is pleasure or business. This is type of trip. And the airline used. What is the airline used? The three airlines, airline, United Airlines, Delta, or Southwest. These two variables assume that they are independent. Okay. The question, what is the probability that a flyer uses United and is a business traveler? So he is asking about probability of U, United, and or intersection, business traveler, and B. Because the two variables are independent, so the probability of the intersection would be probability of U of the first times probability of the second. Probability of flying using United Airlines is 0.6, 60%. And probability of flying for business is 30%. So this would give you the probability if using United and business traveler at the same time. The answer is 0.18. All right, I'll stop here and next time we will solve more examples about multiplication rule and independence.